Hello everyone. Today we'll be solving EDEXCEL International IGCSE 921 Chemistry Paper 1CR Jan 2022. In this particular video, we'll be solving from question number 6 to question number 8. This is a part 2 video. If you want to watch the part 1, then it is in a playlist. You can play it from there. Question number 6. Omycin is an organic compound that gives some plants their particular smell. The molecular formula of omycin is C10H16. Calculate the relative formula mass of omycin. Whenever we are asked to find out the relative formula mass of anything, we are going to write MR and then we're going to write down the formula of that particular compound first. All right, this gives us a clear understanding what we have. So we have 10 carbons. Each carbon is 12 multiplied by 10. And then there is like 16 hydrogen. So each hydrogen is 1 and then multiplied by 16. So the total comes out to be 136. Using omycin as an example, explain what is meant by the term empirical formula. Guys, these questions like this are very important because they are always repeating. So please memorize. So empirical formula shows the simplest whole number ratio of atoms present in a compound. The empirical formula for omycin, as we can see over here, which is C10H16, will be C5H8. Part C. The displayed formula of omycin is given here. We can see there are 3 carbon-carbon double bonds. So this is an unsaturated compound. Explain why omycin is described as an unsaturated hydrocarbon. So because we can see that the omycin contains carbon-carbon double bonds and it contains, all right, so the reason why we're calling it unsaturated is because it contains carbon-carbon double bonds. The reason why we're calling it a hydrocarbon is because it contains carbon and hydrogen only. Part D. Ocimene is an alkane. Which of these types of reaction occurs between ocimene and bromine? So, since it is an alkane, carbon-carbon double bond, so bromine will have addition reaction. It's not a polymerization reaction, precipitation, or substitution. Bromine just simply gets added to it. So it's going to be addition reaction. Many alkenes have the general formula CnH2n. Suggest why ocimene does not have this general formula. Because in the ocimene we can see that there are more than one carbon-carbon double bonds. If a particular compound, alkene compound, that it has more than one carbon-carbon double bond, it cannot match the general formula CnH2n. Ocimene can take part in combustion reaction. Complete the equation for the complete combustion of ocimene. So C10H16, when it reacts with oxygen, it is going to produce, complete combustion is going to produce carbon dioxide and water. So to balance this out, we'll have to see how many hydrogens we have. So 16 hydrogens. To balance it up, we're going to put 8 H2O, which balances up 16 hydrogen. There are 10 carbon, that means it will produce 10 carbon dioxide. So a total of 10 into 2 plus 8. This number of oxygen atoms will be required. So it will be 28. Now oxygen are diatomic, so divided by 2, it will give us 14 O2 molecules. So 14 O2 will be the balancing number. Guys, questions like these are pretty straightforward. So please focus on the hydrogen and then write down the number of water, focus on the carbon, write down the number of carbon dioxide. And then once you get those numbers, find out the number of oxygen that is needed. And then because oxygen atoms do not exist, they are diatomic. So divided by 2 to get the number of oxygen molecule. And that's how you get it. If there is any oxygen that is included in this particular compound, make sure to subtract it from here. And that's how you'll get a balanced equation. Part F. Two different products can form during the incomplete combustion of ocimene. One product is a solid and the other is a poisonous gas. Identify these two products. When incomplete combustion of hydrocarbons are done, the solid always produced is the soot, which is carbon. So it will be carbon. We can also call it soot, any one of them. All right. And the other poisonous toxic product that is produced is carbon monoxide. Carbon monoxide can bind with hemoglobin irreversibly and damage the hemoglobin. So it's highly toxic. State why the gas produced is poisonous. So carbon monoxide reduces capacity of the blood to carry more oxygen by forming permanent carboxyhemoglobin. Question number 7. Explain the meaning of the term thermal decomposition. So basically the term thermal decomposition refers to breaking up of a particular compound or a substance. But in this case, since we are going to use thermal, so we'll have to do it by heating. Part B, the equation for the thermal decomposition of potassium hydrogen carbonate is potassium hydrogen carbonate turning into potassium carbonate, water, and giving off carbon dioxide. The H2 will be coming off as a steam, and the CO2 will also be coming off as a gas. Now the question says calculate the maximum mass of K2CO3 that could be produced from thermal decomposition of 2.5 gram of potassium hydrogen carbonate. All right, in this type of questions, the relative molecular mass is very important, so we need to find that out. First of all, if we find out the MR of potassium hydrogen carbonate, we'll see MR potassium is, so the mass of potassium is 39 plus 1 plus 12 plus 16 into 3, which totally adds up to 100. Now we need to know the MR of K2CO3. So 39 into 2 plus 12 plus 16 into 3, which is equals to 138. Now, according to the stoichiometric equation, we can see 2 moles of potassium hydrogen carbonate produces 101 mole of potassium carbonate. So we can represent that in a different form, writing like this: 200 grams of potassium hydrogen carbonate produces 138 grams of potassium carbonate. Now, since we have 2.5 gram to start with, so we can start 2.5 gram potassium hydrogen carbonate produces 138 divided by 200 and multiplied by 2.5. And this quantity of K2CO3 will be produced. So the answer comes out to be 1.725 gram of potassium carbonate that will be produced. So maximum mass of potassium carbonate will be 1.725. Now many students, they get confused when the question paper says maximum mass of potassium carbonate. Okay, so what does that actually mean? You see, if we were to do this particular reaction in real life, 2.5 gram, we would have to put it in a crucible. Now, no matter how much clean crucible you take, once you're going to put it over there, and then basically after doing the heating reaction, it is very unlikely that all of the potassium hydrogen carbonate will decompose. And also the second thing is, it is very unlikely that we will be able to recover all of the potassium hydrogen carbonate. Uh, you know, After it turns into potassium carbonate, it may get stuck with that particular crucible. So we might not be able to get it out. So theoretically, all right, if we were to do it in theory, all right, if we were to, sorry, if practically, if we were to do it in practical, we would definitely lose some mass of potassium carbonate, and thereby our final yield of product would be less. However, when doing it theoretically in a copy, we get the maximum amount of mass, which we will never achieve in our real life. That's why says maximum mass of potassium carbonate, because that is only going to be possible in pen and paper. Question number 8. A student uses this apparatus in an experiment to study the rate of the reaction between zinc and dilute sulfuric acid. We have zinc granules, dilute sulfuric acid, we have a balance. So when zinc is going to react with dilute sulfuric acid, is going to produce hydrogen. The hydrogen is going to escape in the form of gas. And as the hydrogen escapes, obviously the mass of this particular apparatus is going to decrease. This is the student's method. Add a few zinc granules to a conical flask on a balance. Add 100 cm³ of dilute sulfuric acid to the flask. Start a timer and immediately record the mass of the flask and content. Record the mass of the flask and contents every minute until the mass remains constant, meaning all the hydrogen is gone. The mass of the flask and the content decreases because hydrogen gas is produced and leaves the flask. The student uses the mass reading to calculate the total mass of hydrogen produced. Complete the equation for the reaction by adding the state symbols. So zinc that we are adding is a solid, and sulfuric acid is definitely aqueous, and the zinc sulfur that is going to be produced is definitely going to be aqueous, and hydrogen that is produced is in the form of gas. Moving on, guys. Part B. The table shows the student result. We can see the total mass of hydrogen produced in milligram, which is suiting because this particular mass of hydrogen is pretty negligible. So we can see, all right, the reaction stops at 14 minutes because after that no more hydrogen is produced. Okay. Plot the student's result. The first three have been done for you. All right. So, okay, we can see the first 3 points has been done for us already. All right. So time in minutes, 3 minute 130. So 3 minute, 3 minute. So this is 3 minute, and then we have 130. So which is going to be here. After that, so the part 2 says draw a circle around the anomalous result and draw a curve of best fit. Part 3. So we can see the anomalous result is over here. The anomalous result occurs at 6 minutes. All right, then the question says to draw a smooth curve. So the smooth line of curve is done. Anomalous result. Okay, we got it all. Part 4. Give a possible reason for the anomalous result. Because we see that it has lower volume, so probably the student has taken the result before the minute was due. So the student took reading too soon before 6 minutes. Determine a more likely value for this result. The more likely value for this result can be found by extrapolating in the graph on that very same point and then going back towards 171. Part C1. Explain how the shape of the curve shows how the rate of the reaction changes as time increases. So from the shape of the curve, we can see that as time passes, the rate of the reaction decreases and it then eventually plateaus. At the end of the experiment, there is no zinc left in the flask. Give a conclusion that the student could make about the observation. So definitely it indicates that the acid was in excess. So the sulfuric acid was in excess, which is why all the zinc has been reacted up. Part D. The student does another experiment using the same amount of similarly sized magnesium granules instead of zinc. The volume of the sulfuric acid. Okay, so the student used the same volume of sulfuric acid but at lower concentration. Explain why it is difficult to predict how the rate of the reaction in this experiment compares with the rate of the reaction in the first experiment. Magnesium is a more reactive metal than zinc, which would make the reaction faster. However, using lower concentration of acid, all right, means the reaction will become slower because of the low concentration. So it is difficult or nearly impossible to know whether the rate will increase or decrease overall. Part E. Explain in terms of particle collision theory how increasing the temperature affects the rate of reaction. So basically, at higher temperature, particles have more kinetic energy. So whenever particles have more kinetic energy, they're going to move more and there will be more successful collision per unit time. And as a result, the rate of the reaction will increase. Guys, thank you for watching the video. Subscribe to the channel and thank you. Bye bye.